Good afternoon, everybody. Today we're looking at how to find the volume of cylinders, continuing our merry way down the road of measurement. And this one, some parts of it look a bit, I don't know, tough maybe, but I think it comes across pretty easy. The key part of finding the volume of any cylinder is that first off, we want to know what the area of that face is. So the cross-sectional face, if you've done other shapes and volume before. Okay, that's not even a very good colour to do that in. So we want to find that there. Okay, once we've found that, the next bit is pretty easy. We multiply that by the length or height of the cylinder. Okay, so hopefully we know that the area of a circle is equal to pi r squared. So if we take pi r squared and multiply it by the height, we can call the volume of a cylinder, or give the equation as pi r squared h times height. Okay, so that's the circle there. That portion is the circle, and then times it by the h, or the height. Okay, so all we need to do now is take that equation and substitute in the values. So volume cylinder is equal to pi r here. So that there is the radius, the diameter, which is 4. So the radius is half of that, which is 2. So 2 squared, and the height is 21, which is there. So we can start working this out and go pi times 4 times 21. Okay, I've just done the squaring there. Then we can multiply 4 and 21. So 2 21s are 42. 2 42s are 84. So we get 84 pi. If you're asked for an exact value, you can leave it as that. And then if we want the approximate value, might mean a little bit more to us though, we do 84 times pi. And our approximate value is 263. Let's just take it to one decimal place, 0.9, because our 8 is rounded up by the 9. And we've got a value or a unit of meters, and that's meters cubed because it's volume. Okay, so as always, if you are not confident with that part there, okay, the exact value, you can just go from here to here with your calculator. Okay, and later on come to terms with the exact values. So moving down a little bit, let's have a look at the next problem. We've got obviously not a whole cylinder, but the same principle applies. We want to find the area of that face. Oh, I don't know why. Got a funny shape there. Try that again. We're going to find the area of this again, and then times it by the length of the shape. Okay. So the area of that can be found a few ways. You can find the area of a complete circle and then half it, or we can put it into, we can do the area of half a circle and just go, right, that must be equal to 1/2 times pi r squared. And there are other ways you can find it. You can just take this, we could take that part there and just divide that by 2 as well, get rid of that. But later on you'll see why I've put the fraction at the front there as a multiplication. So pi r squared multiplied by 1/2, and again we want to multiply it by 24 eventually, so the volume of the cylinder is equal to 1/2 pi r squared times, or we can get rid of that, we don't need that, times we'll call it the height still just for consistency, times the height. Okay, height, length really doesn't mean anything different if you use the same, the correct dimension. So let's now put in our values. So half pi r, that's the diameter again. So we want to half that. So divide that by 2, which equals 4.5. So pi times 4.5 squared times 24. Is that length there? Okay. Now, if we wanted an exact figure for this, in my head, I can't do 4.5 squared, but I can, on the calculator, do half times 4.5 squared times 24, and that will give me the coefficient of pi. Okay, so if I do half, or 0.5 times 4.5 squared times 24, we get 243. So we get 243 pi as the approximate value. Then if we want, as the exact value, and then if we want the approximate value, we just go up here. I've already got that in there, so I can just hit times and bring up pi, shift pi there, and we get 763.4, and the units are meters cubed. Right, so that will give you the volume, how much space that shape will take up. Now the next one gets a little bit harder. So we've got a portion there of it, and here we have another portion, but it's not as simply cut as that one there that we did. Looking for a drink of water, that's gone. So what do we do with that? And that's where the fraction comes in. So again, same principles as last time, all apply. We want to be able to find this face there and then multiply it by that height. Okay. Now we're shown here, that face is shown there as a cross section. And so that we can see it, I'll keep that clear. And we're told that that is actually 78 degrees. So as a fraction, what we've got, up here we had a fraction, we had half of the circle. Here, if we're going to find the area of this green part, that green face there, the area of that, the area of the circle in that example is equal to 78 out of 360. It's 360 degrees in a circle. Okay, that does simplify, but we'll leave it like that for now. So that times our normal equation, pi r squared, will give us the circle's face. Now, the volume of the sector is equal to the same as we've done before. Hopefully we can catch on. We're just going to add a h to the end of our equation. So 78, sorry, I'm going to change this one just here to, that's actually going to be theta, okay? And then we will replace theta this time with 78. But the standard equation, 78 degrees, the standard equation is that theta's there, and we replace that with however many degrees our face of the sector is there. So 78 over 360 times pi r is 4 squared times 10. Okay, now we can take a look and if this has a nice exact value. Again, I'm not going to do 78 over 360 times 4 squared times 10 in my head, so go and use our trusty calculator, and let's kick it off with, where's my fraction buttons? There they are, hidden down here. No? Yes? No, it doesn't look like it. I can't see fraction buttons on this calculator. Or maybe I think I know. Maybe it's that. Okay, cool. I'm going to clear that. There's my fraction button. Cool. 78, jump down over 360. Make sure it's across there, times, so I'm going to do 4 squared, which is 16. I'll just put 4 squared in, times 10. Okay, so this should, so 104 over 3, this is going to end up not as pretty as I'd hoped. Okay, so it doesn't come out as a neat, exact decimal, but we can, if we had to, we could express it as it is, 104 over 3 times pi. We could change it into a mixed fraction, so we can, let's have a look here. Actually, we can use this button that we just saw then. 34 and 2/3, or 34 and 2/3 pi. So we're using our divide 104 by 3, and you'll get 34 with 2 left over. Okay. Now, if we want to go to the approximate value that we had up here before, we can just click that and go, this is equal to, actually, no, I want to, before I do that, take it back to that. Now, I've got that. Now I've got to multiply this by pi to get my approximate value. So we've got 108.9, and it says it's in meters again, so that's meters cubed. So I'll just go over that little bit there again. So I got an exact value by multiplying the fraction, so all the numerals. That gave me that, and I had to keep the pi because I hadn't done anything with that, so I just carried that down. But to get the 108.9, we can, just to go over that on the calculator in case we missed it, we can just go 78, where's it gone? Looking for my delete button, let's get that. We can go 78. Okay, 78, try again. Over 360. Buttons don't like me today. 360 times, actually we don't want that there, we want to get that out of the fraction, so 78 over 360 times pi. I want the times in there because I don't remember this calculator. This is great. When you are hitting one button, it means you hit another. Times pi, cool, got it now. Times 4 squared times 10. Okay, so you'll see that matches what we've got down here now, okay, in our equation. And if I hit equals, everything going right, we again get that tick tick. Okay, so let's write that out a little more clearly again for the equation, the standard equation if we want to find a sector. So the volume of a sector is equal to theta over 360 times pi r squared multiplied by the height. We don't need that there. Okay. And that's the volume of a sector. Hopefully that is helpful, gang. Have a fantastic day. The sun has come out again here. It's nice because it's not raining. And if you like the video, give it a thumbs up or subscribe and keep in touch. Cool. See ya.